Good morning, students. Today we will discuss about law of chemical combinations. So here each and every reaction should follow some rules. Suppose element is combining, or element compound is combining, compound is combining in any chemical reaction. So that combination should follow some rules. Those are called as laws of chemical combinations. So there are different laws like law of conservation of mass, law of definite proportion, law of multiple proportion, Gay-Lussac law of combining volumes, and one more, Avogadro's hypothesis or Avogadro's law. So now we will discuss one by one. First one is law of conservation of mass. So what is law of conservation of mass? The law states that matter can neither be created nor be destroyed, but it can be changed from one form to another form. So this law we can also state it as total mass of reactants is always equal to total mass of the products formed during chemical reaction. So I will give an example, you can understand easily. Suppose there is a reaction A plus B gives C plus D. AB are reactants, CD are products. Suppose I have taken 75 grams of A and 25 grams of B. So these reactants are reacting completely and producing products. Suppose we got 60 grams of C. And what about D quantity? According to law of conservation of mass, a reactant's mass must be equal to product's mass. So here reactant's mass 75 plus 25. So this combination equal to 100 grams. 100 grams reactants. So here 60 grams C produced. Then D must be 40 grams. So 60 plus 40 will get 100 grams. So if reaction happened like this, means the it follows law of conservation of mass. The reaction obeys law of conservation of mass. So one real example we will see. See here, what mass of NaCl would be decomposed by 9.8 grams of H2SO4? If 12 grams of NaHSO4, 3.65 grams of HCl were produced in a reaction, assuming that law of conservation of mass is obeyed. So here the reaction between NaCl, the reaction between NaCl plus H2SO4. What products you are getting? NaHSO4 plus HCl. What they given in the question? Just you see. 9.8 grams of H2SO4, 12 grams of NaHSO4, 3.65 grams of HCl. Just note down these values here. 9.8 grams of H2SO4 and 12 grams of NaHSO4. 12 grams of NaHSO4 and HCl quantity is 3.65 grams. So 3.65 grams. So what they said, this reaction is following law of conservation of mass. Suppose NaCl quantity is X. Then we can write according to law of mass action X plus 9.8 equal to 12 plus 3.65, means reactant's mass equal to product's mass. So therefore you can solve this and you will get X value. So how much you will get X value? 12 plus 3.65, that is 15.65. So here 9.8. So 15.65 minus 9.8. Suppose nearly 15 minus 9 means we will get nearly 6. So approximately we will get 6. Approximately 6. I think 5.85 is the answer. So like that, the problems. Next law is law of definite proportion. This law states that a given compound always contains same elements in fixed proportion by mass, irrespective of the method of preparation. So this law was proposed by Joseph Proust in 1806. So according to this law, what they are saying, a given compound, suppose if you take water, so we have different sources for water. Water will get from bore wells, water will get from some lakes or rivers. Collect different samples of water from different sources and analyze the composition of that water. Composition means how much quantity of hydrogen, how much quantity of oxygen present in the water. So you will get mass ratio of hydrogen oxygen always 1:8. So for example, if you take 2 hydrogens, this is a 2, and oxygen atomic mass is 16. So if you cancel it, you will get 1:18. So this 1:8. So this 1:8 is mass ratio of hydrogen oxygen in water. So you have different samples of water. If you analyze from each and every sample, you will get same mass ratio 1:8. So it means it follows law of definite proportion. A given compound always contains same elements in a fixed proportion by mass, irrespective of the method of preparation. So now we will see one example for this. Here, just now I explained by taking water example. Now this is the experiment. Sodium chloride. In sodium chloride, sodium chlorine mass ratios we are going to calculate. So sodium chloride is obtained by 2 ways. So we have prepared sodium chloride in 2 different methods. One is by direct combination of sodium and chlorine. So that is Na plus Cl2 gives NaCl. So for balanced equation, we have to take NaCl. So of Cl2 we have to take NaCl. Sorry. So here sodium plus half Cl2 gives NaCl. So we have taken some quantity of sodium, some quantity of Cl2 in a bowl, we got NaCl. How much quantity of sodium we have taken? 1.15 grams of sodium, and quantity of chlorine is excess. So 1.15 grams of sodium will combine with specific quantity of chlorine, which is required for reaction, and produce 2.925 grams of sodium chloride. So how much quantity of sodium we have taken here? Sodium we have taken 1.15, and NaCl we got 2.925. From these quantities we can calculate how much chlorine combined. This 2.925 minus 1.15. If you do, you will get mass of chlorine. So that mass of chlorine is 1.775. Then we have taken ratio of masses of sodium and chlorine. 1.15 is sodium mass, 1.775 is chlorine mass. So we got 1:1.54. That is mass ratio of sodium and chlorine. Now this is sodium and chlorine mass ratio in NaCl, which is obtained by direct combination of sodium and chlorine. Similarly, in one more experiment, sodium chloride is obtained by neutralization of hydrochloric acid and sodium hydroxide. You know, HCl plus NaOH gives NaCl plus water. So this reaction you know. So from this also you will get NaCl. Now in this experiment, 1.53 grams of sodium is treated with water. If you treat it with water, you will get sodium hydroxide, which is then neutralized by excess of hydrochloric acid to get 3.9 grams of sodium chloride. So now, how much quantity of sodium, how much quantity of chlorine present in NaCl? How to know? So here, how much quantity of sodium we have taken? 1.53 grams. That sodium will come to NaCl. So sodium mass equal to 1.53. And this chlorine, how to get chlorine mass? So the compound sodium chloride 3.9 grams minus, so in this sodium chloride, how much sodium mass? 1.53. So if you do this, you will get to 2.37. This 2.37 is chlorine mass, grams of chlorine. So now you have to take mass ratio of this sodium and chlorine. So 1.53 is to 2.37. How much we got? 1 is to 1.54. So in before sample, sodium chlorine mass ratio 1 is to 1.54. In this sample also 1 is to 1.54. But both samples obtained from different sources. First one is from sodium chlorine direct combination. Second one is from neutralization of HCl and NaOH. So from these experiments, it is clear that the given compound always contains same elements with fixed mass ratio. Next, we'll go for next law, that is a law of multiple proportions. What is law of multiple proportion? See, if two elements combine to form more than one compound. So, for example, sulfur and oxygen, two elements combine to form more than one compound. Suppose SO2, sulfur dioxide, SO3, sulfur trioxide. These two elements combination giving two compounds, that is SO2, SO3. Then the masses of one of the element that combines with the fixed mass of the second element will be in a simple whole number ratio. The masses of one of the element means, suppose oxygen mass, if you take one of the element means oxygen mass, that combines with fixed mass of the second element will be in simple whole number ratio. Now I will show you calculation, then you can understand easily. So now sulfur and oxygen combination we got SO2 and SO3. Now you see here sulfur weight is 32 and oxygen weight is atomic weight 16 and 2 oxygens are there, so 32. So 32 grams of oxygen combines with 32 grams of sulfur in SO2. Similarly in SO3, sulfur 32 grams and oxygen 48 grams. So here 48 grams of oxygen combines with 32 grams of sulfur. In SO2, 32 grams of oxygen combines with 32 grams of sulfur. So here sulfur weight is fixed. Here 32, here also 32. If you take mass ratio of oxygen, which combines with fixed mass of sulfur, that is 32. So oxygen mass ratios I am taking, that is 32:48. How much you will get? 16 2s are 16 3s are 2:3. So that is only law. What is law? Now you see, by seeing this example, you try to understand the statement. If two elements combine to form more than one compound, sulfur, oxygen, combine to form sulfur dioxide and sulfur trioxide, the masses of one of the element that combines with fixed mass of the second element. Masses of one of the element, here one of the element we have taken as oxygen. So the masses of oxygen that combines with fixed mass of second element, that is sulfur, will be in a simple whole number ratio. Yes, it is in simple whole number ratio, that is 2:3. So this is called as law of multiple proportion. Next, Galois of law of combining volumes. What this law states? When gases combine with each other to form product, they do so in simple ratio by volume, provided all gases are measured under same conditions of temperature and pressure. So let me explain with example, you can understand. With a direct statement it is difficult to understand. So I will explain through example. So now there are two gases are combining. So here, for example, nitrogen. So this is nitrogen and this is a hydrogen, and nitrogen hydrogen combination will get ammonia. Will get ammonia product. Suppose I have taken 1 liter of nitrogen here and 3 liters of hydrogen, then I am getting 2 liters of ammonia. And one more, if you take one more example, hydrogen, oxygen, we are adding, we are getting H2O vapors, suppose vapor state. So here 2 liters hydrogen I have taken, 1 liter oxygen I have taken, I am getting 2 liters of water. So from these two examples it is clear that these are gaseous reactions. First one gaseous reaction, second one also gaseous reaction. So when we are taking reactant volumes in whole numbers, so products also we are getting in whole numbers. Here also 2 liters, 1 liter gives 2 liters. So what this law states? In a gaseous reaction, always gases reacts in simple whole number ratio and will produce products in simple whole number ratio. So in a gaseous reaction, the volume ratio of reactants and products always bear a simple whole number ratio. So in first case, what is the volume ratio? That is 1:3:2. In second case, what is volume ratio of gases? That is 2:1:2. So like this, all gaseous reactions bear a simple whole number ratio. Next, Avogadro's hypothesis. What is Avogadro's hypothesis? Under similar conditions of temperature and pressure, equal volumes of all gases contain equal number of molecules. So, very simple. Again, you take different containers. So, different containers with equal volume. So, container volume should be equal volumes of container. So, one more container I am taking with the equal volume. So, these containers, all these containers kept at same temperature and pressure. At same temperature and pressure. And volumes also same. So, V liters container, this is also V liters container. So, here I have taken oxygen, here I have taken nitrogen, here I have taken some sulfur dioxide gas. What law is saying? So, if you keep different gases, means equal number of all gases at same temperature and pressure contains same number of molecules. Suppose if you find in this container there are 200 oxygen molecules. If you find there are 200 oxygen molecules, so you no need to calculate in remaining two containers. No doubt in this container also there are 200 N2 molecules. Here also there are 200 SO2 molecules. That is Avogadro's observation. So he made a statement that is, at same temperature and pressure, equal volumes of all containers, equal volumes of all gases contains same number of molecules. So this is Avogadro's law. Thank you.